Welcome to Retro Upgrade. As you can see, I'm in front of the camera. This is because I have big news and I thought it appropriate to be in front of the camera. If you want to see more of my beautiful face, just leave a comment below and I'll see what I can do about the face cam. Now for the news. I got sponsored by PCBway. Yeah, shocking. I know. I'm as shocked as you are. Anyway, I'm really happy about the news. That means I'm doing something right in the YouTube space. That's the way you know you have succeeded in YouTube. You get sponsored. I'm going to be doing content for them now, so you should expect 1 to 2 videos a month with a PCBway sponsorship. Some project videos where I make stuff with their tools and services, and some where I just give them a shout out. For those who don't know what PCBway is, it's a big company that makes printed circuit boards and does other stuff like 3D printing. They do SAS, SLA, and FDM printing. Also, they have some different manufacturing like CNC milling, sheet metal manufacturing, and injection molding. So they are quite diverse, and the prices are pretty reasonable for the other services, but their PCBs are unbeatable, according to me at least, because it's €5 for 5 PCBs, and the shipping is really cheap as well. You have to wait a long time for the cheap shipping, but that's no problem for some hobbyists. And I'm going to be starting off this video with showing you how you can order something. I'll do it a little longer than I'm going to do it in the future, just to make sure everyone's on the same page and knows what I'm talking about. Otherwise, I'll shorten the sections down. Over to the computer. Okay, we're at the computer now. So just open your favorite browser, type in www.pcbway.com. You should get there. I'm logged in already. You can create an account if you want to. I'm not really sure if you need one to order, but you will find out eventually. Here you can see the different services they have. They have a lot, but their main service is PCBs. Okay, so let's make it easier for us. Let's find a shared project. They have thousands and thousands of projects for free, like you can see here, and these are really cool. Let's choose one at random. Oh, look, I found my own project. I made this with Richard from Learner Electronics Repair for one of his sponsored videos. This is designed for a milliometer thingy that finds shorts in PCBs. This is really, really handy. This is a 3D printed case. It wasn't too good of a design, so it's outdated already. I'm going to update the design eventually. So this is what it looks like. You can see here the bill of materials and what you need. We did a small guide. This is perfect. It's a really nice community feature to have this. But the best part is you have the order capabilities. You can order the PCB instantly with the uploaded Gerber files, or you can order the PCB with assembly, so they build it for you. I think the switch is not in stock, so everything else should be fine. Okay, let's try to order this. It will load up everything. Okay, so I screwed up the Gerber files. It's not visible here, but they do turn up like they should. I'm going to fix them later and upload them again. But they do show up normal. So what you need to do to order something is just follow these and check the ones you want. Of course, if you're new to PCB printing or PCB ordering, there's a load of stuff here. So I'll go through it slowly for you. First, choose your region so you get the right shipping. So I chose Spain, and then I chose AliExpress because I have some issues with DHL. Never arrives for some reason. So I'm better off just waiting. I could go global standard. I have to try that. Okay, so After you've chosen your carrier of choice, I chose PCB or AliExpress just because it's cheap. I'm a really cheapskate. Okay, so you have the sizes of the PCBs right here, and you choose a single piece normally. You can ask for a panel that makes a big panel and a lot of them in one panel. Not really worth it for small batches, but you can do that if you want. And then you have the quantity right here. We're going for the $5 deal. Like you can see here, it's $5 for 2-layer boards. We're going for a normal PCB. You can make aluminum PCBs and others that I really don't even know what some of those are. But there are, it's cool that you have the options. This is the standard, I guess, because it's pre-chosen. This is the thickness of the actual PCB. I usually leave everything on default. It has a little picture also to show you exactly what's. This is the minimum track width and the spacing between them. This is only important if you actually design it, because it will be pre-selected what you need for the PCB. Minimum hole size, this also doesn't really matter, just leave it at default. If it has really small holes, you have to pay a bit more. Red is a really nice color for this. Like I'll show you after the video here, or after the demonstration. White silk screen, yeah, that's what we went for. Edge connectors, no. If you make your own video game cartridges, this is what you want to tick. And for the surface finish, normally the standard works, but if you want edge connectors, for example, for video game consoles, use immersion gold or hard gold, so it doesn't scratch off, and it has better contact. Tinting vias, yeah, just leave it at default. 1 ounce of copper, that's fine. If you're going to do power traces and stuff, do thicker copper. That depends on the project. And remove the product number. This is a little weird for people that don't know, but they put the product number on the actual PCBs so they can keep track of them when they're making them. And if you want it removed, you have to pay a little extra. That's fine. It's not expensive. 150 is fine. You also have the option to special requests, so that's good. SMD stencils. These are quite nice if you have a lot of components and are thinking of using solder paste to solder down stuff. And then you have the assembly service, so they can actually pre-make them for you with all the components on, or most of them. There are some that they don't put on, but that's fine. Now, I just left everything at default except for the color. That doesn't change the price, it seems. So let's go for calculate, just in case if it changed. Nope, it's still really cheap. It's $5 and $3.61 for the shipping. So $8.61 to get 5 prototypes. That's amazing value. You can see you have some express options to get it done faster, but 3 to 4 days plus the shipping time. In my case, it would be a long time because I chose the cheapest option, but that's my own fault. And then we go to save the cart. And then you just need to wait for them to check your PCB. They usually review it first, so it doesn't have any major faults at least. And then after that, you can just purchase it using one of the many payment methods they have. So you should find something you can use. Okay, let's go back to some final words. I would like to say from me and my little helper here, thank you PCBway.
Thank you, PCBway.
Bye.
Bye.
Okay, after the big announcement, let's get on with the video. Sorry for the long announcement video, but I wanted to make sure I got everything and explain the situation. Okay, so I have a few things here in front of me. I got a shipment of stuff from AliExpress. I've been waiting a long time. These have been rejected 3 times in post office and sent back. So I promised I would make a video about making a case for this. This is my mini power supply. It's a XYS3580. So it's a 0.6 to 36 volt power supply, and it handles up to 80 watts. So it's quite powerful for this size. I have some alligator clips from the last use I did. So what I want to do is make a small containing box for this because it has live wires back here. I don't want it shorting out anywhere. The live wires it takes in, I think, everything between 5 and 30 volts. I will go with a 19 volt laptop power supply that pumps out 100 watts. That should be enough to not limit this. This is a constant current, constant voltage power supply. It also has a lot of metrics and stuff, but I don't want, I don't use those much, but it could be useful sometimes with the memory function. I wanted to place it like this inside a small box, but I wanted to do it with a few extras. So the box itself will contain the unit, has to have ventilation holes for the fan, and input, output, that's where these come in. So I'm going to change out the plug on the PSU from the laptop and put one of these in this, so I connect it directly to it, and it passes the power directly to the unit. Easy enough. This clips in, so you just have to design around the clips on both sides. So easy enough to make a box that can hold that, but I want to make the base magnetic. So I have a few magnets here. I'm going to 3D print holders for these inside. And I'm going to check the polarity, of course, so they all are facing north or facing, so it doesn't make electromagnetic interference. And these are the banana plugs. These are going from the output side directly to the front, so I can plug in alligator clips like this, or my probes. Okay, let's see if I can get my hands on probes. Something like this, so to pass current through stuff. You can also use normal probes, obviously, or even wires. But these I'm probably just going to be using two, the black and the red. I bought a multi-pack because it costs the same as two. So important when making a box. So the dimensions. Important dimensions on this is space behind, so you have to measure a little bit extra so the fan doesn't bind. Also the clips where they are positioned and the size of the internal box. So you have this overlap, this lip right here. See, it has a lip all around, so that will hide any imperfections and stuff. So you just need to make sure that the clips have something to grab onto, and that's pretty much it. This is going to be a design 3D print video, and I'm probably going to make a few versions before it gets completely done, but that should be fine. I'm still quite unsure about the plugs because they are quite hard to pull apart, but I'll make it work. These can be used for another project. These are banana plugs. These are the cheap kind with the locking ring. As you can see, it takes up quite a bit of space back. So I'm going to be soldering wires directly to these. It has the small hole here. And you just need to measure the inside diameter and put a small gap extra, so this fits. It also has a lip, so it just slides in, and then you screw it from the back. But you have to calculate that the wire is going to take up a little bit of space backwards as well. And like I said, magnetic feet. There are a few ways to do this. You could just glue them on the bottom and make a flat surface. I'm going to go with actual small bump feet that hold these inside. So I glue them inside with super glue. That should be good enough. So I have a power supply right here. It's metal. It's my soldering iron and air station, everything in one. That's yeah. So and I can actually put the power supply on it, so it sticks. These are also quite heavy. They are ferrite magnets. I have a magnet right there. So they give a little weight to it. So I don't want it tipping over with the leads when you pull on the leads. I want it to be quite stable. So I'm actually thinking of putting in a metal plate as well in the bottom, so it weighs it down. But I'll check in the design stage and see what we do. I can show you the leads I bought as well. These are the cheap kind. This wasn't expensive at all. I think 5 of these were like €1. This one was the most expensive part. It was 20 something euros, so it's not too bad. These were like 50 cents. The magnets I've had forever, but I don't think they're expensive at all. And I bought a few leads. These were €1. Alligator clips just to do voltage injection and stuff. These are really good. And these do plug in quite satisfyingly. If you have probes with outer shield, you need one of these with a hole on the sides. So let's see if I have some probes. Yeah, from a multimeter. So you see it has a small sleeve on the outside, and this outer hole lets it slide in. So really handy to have. When you buy these, they come covered as well, so be careful. Otherwise, you have to cut off the shielding. That's no good. Buy them with the hole. They work with and without shielding. Okay, I'm just trying to organize here. Okay, so let's go over to the computer and I'll make a rough sketch in a drawing program. I normally use Krita for that. And we can see what the design should look like. Bear in mind, I suck at drawing, so this is not going to look good. Okay, over to the computer. Okay, so we're at the computer. I use Krita for drawing because it's free and it does everything Photoshop does. Not sponsored, but I'm sponsored by PCBway. I'm really happy about that one. As you can see, I'm been using the assets. Okay, so let's just pick a big canvas. Presets. Yeah, ICE A3 should be fine. Okay, so normally I do a rough sketch to see if the design looks okay. I have a drawing tablet, El Cheapo 10-inch. It does work. It's a Parblo branded one, 610 I think the model number is. Anyways. Okay, so let's make first the faceplate. Doesn't need to be perfect, just a rough outline. Just to get the feel of the design. And this is the knob. Okay, really nicely done. Let's see, and there's a button right here. The screen is about this big. So you don't need to be this thorough. This is just so I get an idea. So my idea was making something like this that's bent back a bit, has a little base. This goes up like this, and this is like a triangle back. So this is all solid. Let's see over there. So let's go for the eraser. This works. Okay, so this is pretty much what I want, and it will have 4 small feet, one on each corner, that are magnetic, so I can put it on stuff like my bench power supply, so I can keep it in place. And I was thinking of putting the jack on the back side, and then we have the 2 banana plugs down here. Let's do this. And because this is magnetic and probably weighted, I was thinking of putting a weight down here so it doesn't tip over to the sides when you pull on the plugs. This should be quite comfortable to use, and because it's angled backwards, you can actually just see it from everywhere. It has some glare issues, the small screen, but at that angle it's actually just pointed up towards you. The angle here, this one right there, I think I'm going to go with a maybe 70-degree angle or something, so like this. I'm going to round it off so it looks better, but so it's essentially a triangle but with rounded corners. So this looks good enough for me. This is usable. I've been promising this video for a while. So let's go over to what's it called, Freecad, and start designing. So I usually start with the bottom or the interfacing part. So I don't know if I'm going to be using screws to fasten the front lid to everything else, like this. I have inserts, metal inserts for plastic, so I can screw normal screws into. Or if I'm going to print it as a whole piece with a cutout underneath, so I can screw the lid from underneath. That works as well. Maybe the feet can be screwed in. This part would be separate from everything else. This is the internal lines, by the way. So that could also work. So you screw this to this and you print this as a whole entire piece. That should also work. I need to add ventilation holes, and I'm probably going to put them in the back right here. Okay, let's go over. Okay, so start a new project. I'm in the parts design, so create a new body, create a new sketch inside the body. I'm going to be working from the side. It's easiest for this design right here. I'm going to start sketching this side, so let's go for that. So let's start out with the easiest part, a triangle. Doesn't need to look exactly like the image. Okay, so it's over constraint. So let's remove one of the constraints, the parallel one, because it's constrained. Oh, it's constrained like this anyway. So let's see if I can make this equal distant to this. So these are going to stay equal distance. I don't know what constraint. Okay, the point on line, I'm guessing, because it's not needed because one of them already is on the line. Cool. And then we need to put in a size. So let's check 40 plus 39 plus 20 to I get the face in front. Let's go here. So let's make this 100, or 99 should be the correct number, but 100 is nice and round number. This is a little bigger than I expected. Well, it's fine. And then we need to think about this, because do I want to round it out now or later? You can do it with this tool right here. You can make chamfers, but you can also do that later, so that doesn't really matter. So we can do a triangle like this and put in the values we want, like the angle here. I've tested a bit, and 60 seems to be a nice angle. So I can view, I'm sitting up here and then looking down on the screen, so that angle is fine. And the angle also gives me space for the actual PSU and the banana plugs going in on an angle. Same for the power cord is going here. So let's just extrude this and round it out later, or maybe it's better to round it out now and get some round corners and get the size right for the front panel. Could also be beneficial, I guess. Let's try this route from rounding it out inside here. So you choose one and the other side, and it rounds it out. The only problem with this is you lose your constraints. So you have to choose the point, choose the line, point on line. Every time you do a rounded corner or something, just check, move the model so you can see where it fails. Now I still have the constraints from side to side, but I'm going to lose them when I do this. So you can still do that afterwards. From there to there, from there to there, and let's make these points equal distance from each other. From here to here, equal distance. Yep. But you can see they're not on the line anymore, so let's choose one of these and put them on the line. That's on the line. This one's not on the line, so let's put that one. There are two ways of doing this. You can also make it parallel with this one, like this. That also works. Now, what's stopping us from effectively terminating or making it stable? Let's give this a length of 100, just like we wanted. So the screen goes in between here. This gives us a bigger chamber to put it in. Don't forget there is going to be a thickness all around this as well. So it's hollow, but it still has walls. Okay, and I don't want too big of rounded feet. Okay, that looks good. I need to set the width between these 2 points. From here to here. Let's say 120. That's close enough. That looks good. And then the height from here to here. I'll be 80. Can we say 80? No, I can't. 80 was too little, because if I go 80 it crashes. Okay, so let's go again for that one. So 85 I'm guessing would be the, or 83. Just have to test out and see what you like. So okay, this looks nice. Let's go. Close the sketch. The sketch is chosen. In this workbench it's called padding, the extrude function. So let's pad out 92, and 92 because you have 72 here for this, and then you need some space on the sides just to make it look nice and be more stable. So I'm going to put 10 millimeters on each side. That makes 92. Okay, so let's go. Press the OK button. Now this is done. Now you need to make an indent here, a hole to hold the lid and the feet and stuff. But how do you make this hollow? There is a button called thickness. You can use it straight ahead, but I want to make the thickness go inward. So, and for some reason it doesn't work this way. As you can see, not working. So let's cancel this out. Let's make a sketch connected to this surface, and let's make a bounding box. This will be the lid or the hole. We need to bring in some external geometry with this one right here. This one, this one, this one. This won't show up in the actual sketch. These are just for reference. And let's give this we don't need to give it a size, because we can actually just reference the outside. From here to here, let's say we want 5 millimeters on this side. We want a little bit more on the sides. Oh, maybe not. Let's go for use the point and then the line. From here to here, let's put 5 here as well. And do that all around. So because we can't move this way, so you just need to put 5 here. And the last constraint is actually this one, so let's put 5 here as well. And it's constrained and it's inside. So what you need to do is close, actually pad this out, but not that much. Pad this out 0.01, or yeah, that works. It's slightly padded out. Now choose this and use the thickness, and now you can use the make internal and you get a nice clean internal thickness. So you can go up quite a bit with this. I want about 2 millimeters would be fine. It breaks after a while because the lines intersect. This makes a good size hole with some anchor points for screws. So let's do that. Okay, perfect. Now onto the faceplate. Let's go here. You need to press OK to finish the last step. This is still the thickness command. Now choose this, new sketch. I want to make the actual hole for the PSU and the banana plugs. So let's make a rectangle and 2 circles. Don't bother about the sizes for now. We know this is 39 because of the image, 39 and 72 wide. So let's go for that. And those are the inner diameters where it's going to latch on, and the bezel is actually slightly larger, so you have to think about it because it can interfere with the sockets. Okay, so 39 here, and let's put 72 here. Okay, so it looks okay. And I wanted 10 millimeters space from the sides, from here to here. I haven't brought in the reference yet. Let's do that quickly. There we go. We have all the reference points we need from here to here. Put 10. So it should be from 10 from here to here because of the calculation we did. Now I was thinking of making 20 from the top, but it counts from here, and this is about 10. So let's say 10 from the top, from here to here, 10. Now let's see. So let's make this construction geometry as well. I know this is quite a roundabout way of doing it. You can just measure and eyeball it. That works too. From here to here, and use this as a center point. No, that didn't work out. Okay, so I screwed up again. So if you press escape too many times, you go outside the model. Just go to the model and double click on the last sketch. There we go. So Control Z, no. Control Z again. There we go. From here to here and there. It's over constraint. Which one? 16. This one. Okay, so let's delete the constraints. Now this keeps them exactly spaced apart. So the only thing you have to do is find a place you like. Choose one of them. Put a distance constraint. Let's say 21. And from here to here, let's say it's 10. No, let's say 12 because they have bezels. There we go. That works. Close. Now, this is called differently than the other one as well. You would think you would use the whole option, but no, use the pocket option. So let's go. That make the nice little hole. Okay, let's go for the power plug on the back. Same here, you have to press OK because I'm still in the old tool. There we go. Now I want the hole for the power coming in down here, and then I want a mesh or something here to let air out because it has a small fan. So let's So let's go for that first. Let's bring in the geometry this time from the beginning. It's a pain in the ass that you can't choose the actual face. That would be a lot easier and then just clicking all the lines, but hey, they'll get there eventually with this free program. It's good enough. Now let's put this somewhat in the middle. I know how wide this is, so from here to here it's 92, so 46 would be the middle. So let's do this from here to here, 46. And I don't want it at the bottom because it's going in an angle, it can hit the bottom. So let's give it a little room. About 10 from the bottom is fine. That's good enough. And this needs a size. This is the size of the plug. I measure it from the bottom where it screws on, and it's 7.5. So let's give it 7.6 or something, just to give it a little extra room. And this is set to sketch geometry, so what's it called, construction geometry. So no, I want it as a normal geometry, and we have to remove this. So let's do, I don't know why. Oh, okay, there we go. So it was set to make construction geometry only. Okay, so let's make the hole first. I have an idea on how to make the vent. So close this, pocket. See, the workflow is quite nice. So now choose this again, press OK, new sketch. Now I want to a repeating pattern. So you can choose whatever you like as long as it's stackable somehow. So let's see. If I choose, let's go for hexagons. That looks really nice. And let's make a small array of 2. So let's work here. So let's make this completely parallel. This one as well. So size, make it easy to print. I guess 10. If you make it too small, the details are too small and printing goes bad. So let's go for 10. So diameter 10. Same for this one. We can make these equal. That's good enough. Okay, and then we want the spacing to be about right. So we can make them this and this, for example, be parallel. So it stays there, and we can put a distance from here to here and put the distance between them. So like this, let's put 2 millimeters. That looks nice. Now we need to constrain these so they don't move. So let's say from this side to this side, we need to bring in the geometry again. I forgot. That's a recurring thing. New applications are hard to get into just because of this. But when you get the hang of this application, it has everything, so you don't need Fusion 360 anymore. But for now, it's taking me a while to make videos with this. But it's fine. This is the 5th attempt, by the way. Not that it matters. If it works, it works. It just takes extra time. So let's put 5 millimeters from the corner, because I don't want to be dealing with that it gets into the sides. Same for here. Let's put 5 from the top. And let's choose the star point here. There we go. And let's make this 5. Okay, so we have a recurring print, or whatever you want to call it. So there are a couple of ways of doing this. If it's staggered like this, it looks better. You can just make one, but then you have a line of them on each row, so it doesn't look too good. Okay, so what you do, 0 on the rows, just keep everything. straight down, almost right. 19 looked fine. That looks good. Go close the sketch. See the pattern. Just pocket the pattern. And press OK. And now go over to the pocket. And you have a tool to actually copy these in a linear pattern. You choose the axis you want to work with. I won't want to go that way, so I'll choose the red one. And then you have the length. It's over here somewhere, so let's bring this down to 10. See? Now, this is the total length of the entire thing. So if I put one more, it will start breaking. So you have to know how wide you want it. So let's say 72 thereabouts, and put in a few of these. See the spacing changes when we put a few more. There we go. That looks awesome. That will give it enough ventilation. So let's go, press OK. Now we want a lid for underneath, but I want some feet as well with magnets inside, so I can put this on anywhere. So let's make a new body. So it's external from this. So a new body. And we want these features from this body, but we can't because it's another body. So they don't register. So what you do is you use one of these. So you choose what you want to copy over. So let's say those two. Choose this. It shows the two faces. Press OK. You have the shape binder in this body. This is the other one. You can actually hide this now. Let's see. I pressed the wrong button, I guess. You choose the body and press space. There we go. And then you make the sketch here. You choose this. Okay, it's this plane right here. Okay. Now you can't bring in this otherwise. So let's bring this in first. So this is so we have the sizes. Did it break already? No. It did not. I want the outer ones as well. Just me missing. Nothing else. There we go. So these will help me align the bottom box. These don't show up. So I'm going to do this a little bit different. I'm just going to make a box as big as this, and I don't actually need the middle part. But this will help me later on with the whole spacing and stuff, because this is the plastic inside. Okay, so let's just close here. Extrude, that's pad in this case. Now you will see something a little weird. If you press space, it extruded to the other side. So what you want to do is go to the pad and reverse it. So let's find reverse here. Through. So it goes down instead. It should. It did not. Am I on the wrong place? Yeah, I don't know why it's not working. It should. Refine, reverse. Yeah, no, yes, correct. There. Oh, press enter. My bad. And I don't want the height to be 10 millimeters. 3 is fine here. Okay, so it got stuck. Just go out and in, Three. I was trying to change the wrong one. Actually, I don't know what this one does. Okay, so this looks nice, just like a little lid. Let's see if we can make this look even nicer. So we can hide the other body now. We don't need that. So you use this. I want some feet with magnets inside that are a specific size, so I have to accommodate for them. So let's go. Let's use the sketch. Bring in the geometry. It always helps. Fusion has a big advantage there because you can use old geometry to make new one instead of bringing in a lot of stuff. There we go. Let's make the feet slots, I guess. Or we can make squares and make them rounded. Yeah, let's make squares. Good enough. So, okay, so let's make 4. I want 4 feet. Okay, so I want the screws right here on each side. So those are fine. The magnets are about 10 by 20 millimeters and about 4 millimeters thick. So we have to think about that when we are designing. So let's choose 27 is too much, so it's 20. So let's give it 2 millimeters inside. So you have 1 millimeter on each side extra. So 22, and the width was 10. So let's give it 12, 2 millimeters on each side as well, or 1 millimeter on each side. Okay, so this looks nice. So let's make all of these the same, and then equal. Same for the tops, and equal. So that makes this a lot easier. And you just have to put the length from here to here and put in a value. I probably selected the wrong thing already. From here to here. Yes. Let's put 5. I don't want them exactly at the corner. That wouldn't hurt, but I need to stick in the magnet from inside, so no. This is better doing it this way. Put it 5 millimeters. If you don't understand, you will in a few seconds when I do the magnet bit from inside. From here to here. Let's put 5 as well. From here to here, 5. This is repetitive work, but it will be a payoff at the end because this doesn't exist anywhere. And you can put your logo on the fin, on the cooler, or wherever you like. I don't like having my logo everywhere on everything I own because it feels a little dirty, I guess. Trying to self-promote yourself. So this is stuck parallel up and down as well. So it only needs this constraint right here. So 5. Okay, so that looks good enough for me. We're going to chamfer the feet later, so they will look nice and rounded. There we go. Let's bring them out. So let's pad. These are way too big. So 10 is too much. The magnet inside was 4. I want it inside here, but we need to leave some thickness so it doesn't break as well. So let's say 2. This is 3. So let's leave 4 down, so we can leave 2 and then go to 4 down. Let's make this 3 then. So this is 3, this is 3. That means if you go down 4, we should have 2 millimeters left on the bottom. Okay, let's press OK. That looks good, but where do you put your magnets here? So do you see this annoying shape thing just click on it and press space, and you can hide it. Okay, so how do I get the squares from here to here? Easy. You choose this, you use the sketch, you flip it over, and you import external geometry again. You don't see anything, but on the other side it plops up, so just make sure you click on the yellow lines. Okay. So there are 100 ways to do this in this application, but this is my way. This is the closest to Fusion workflow you can get. There we go. Now we want squares inside that are a little bigger than 10 by 20, so I can slide in the magnets. So I don't want it snapping to anything. I just want squares inside. There probably is a way to make a recurring or mirror or whatever. I'm not going to bother right now because I just want to finish this and 3D print it. I have to get the video out because of this time constraints I have. It's been hard. So let's say 11. And let's say we want half it has a millimeter or so from each side, so let's say we want half a millimeter from here to here, 0.5. Extremely important, use 0.5 and not comma 5 because it will break everything. 21, it's 20, so that gives it a little space. Just bring it down from this to this, 0.5, that's good enough, and it's the same all around, so we can stick in the magnet. There's some wiggle room. I use glue to keep it in place, so that's fine. And let's do this for all of this. So we choose the same line, equal, and then the tops. If you're going to do repetitive work, at least Freecad makes it easy. Okay, perfect. So let's go here, from here to here we want 0.5, and from here to here we want 0.5, and we want that on all of them. CAD work pays very well if you're good at it. This is why, because it's repetitive and boring, but you can make some cool stuff. So from here to here, 0.5. I know I'm repeating myself, but that's the point. And from here to here, 0.5. There we go. Nice and square. So the idea with this is to make a small indent. So let's go. Let me just think. Yeah, we don't need to do more. So you use the pocket tool again. I don't want it 5 millimeters down. 4 is fine. So we have some meat on the bone down here, otherwise it will be too close. So this looks okay. I don't see any protrusions or anything, so let's go for this. Press OK. Now we need some holes for the screws. I'll bring back the shape binder so I can see where I want the holes. See, it's useful. So I want to make this. Now I have the guides on where the holes are, so, or where the plastic is, so I can put some screws. So let's go from here and here. I have some machine screws I want to use. They are, I think, 3mm machine screws, and I'll put a hole a little bit bigger so it doesn't bind when I push it in, because it's going to screw into a melt-in screw thread. Can't remember what they're called right now, but yeah, I'll show you in the video here. You'll see them when I put them on as well. There we go. These are parallel. Let's make the sizes the same for all four. 3.15 would be nice. And just this, and this equal. Perfect. And then let's make these parallel as well, and make these horizontal. Same for this. So now I just have to fix one. So the height will not change the height on the other ones, but the positioning will. So let's go. You can also make it so the height is mirrored across. You have to make a line in the middle. So we need to bring in some geometry to place these. Let's go again. This one, this one, this one, and this one. Press it 1, escape. If you go to, you jump out of the sketch. Okay, so let's see. The feet are here. We can actually pull these out all the way here. Let's give one of these a dimension from here to here. No, you don't want to do that because it's on an angle. So from here to here, it gets a straight line. There we go. You see? Let's say 10. Well, that's practically in the middle there. That looks nice. Let's do the same for this side. And then from the top down, we want it in the middle of this plastic piece. So it could be all scientific and measure, but 2.5 should be fine. I think these are parallel, so it just brought that one up as well. And let's do the same for these. This to this is 10. Oh, it brought it over by itself, so just the height. So this is also 10, I'm guessing. Yeah, it is. So it's just this. Okay, perfect. And then we put 2.5 here as well. And all of them are constrained. So let's just make the hole. Let's hide this as well, the yellow one, because it's annoying. Choose it, space. Really easy to hide stuff, at least. Okay, so let's close the sketch. You can see it's under tasks, and close. Now you can see these. You should be able to pocket them out. I have to learn how to do the hole thingy. Use the hole. I don't really know how that works. Haven't watched enough YouTube videos for that. So this looks good. We are going to chamfer these so they don't look too horrible. And let's do some indents. I have some... oh yeah, I have to press OK here as well, because otherwise the holes don't stick. There and there. So you have to... If you're going to chamfer this, it's because I want it flush. My screws have a chamfered top, so they will sit flush if you have a chamfered there. So see if that works. 1 millimeter is too much. So 0.5 maybe of a chamfer. Yeah, that works. So it's not a big screw by any means. 0.7. If it breaks like that, you just try until it breaks. So 0.6. Yeah, 0.6 works. The biggest chamfer I can get away with there. That's really good. No. It's going to be a pain to screw these in because of the magnets inside here, but yeah, they won't fall away from you at least. Okay, and let's make the feet look nice. And let's just choose the tops of these. Oh yeah, press OK so the chamfer stays. Let's make a chamfer for these as well. That looks fine, actually. It's using 1 millimeter. That's good enough. And also, you can chamfer the inner corners to put the magnets in. Because I put some spacing in between, that's fine. Do I want to chamfer the corners? Maybe up here. Let's see. Maybe the screw holes are too close to corners. We'll see in a second. Ah, crap. I forgot to hold in control. That happens. So it's rounded off. It looks okay. Screws are quite a bit in. So yeah, let's go for this. Okay, let's go to the top part. Model. And it's hidden, so choose it, space, you should see it. That looks really good. We just have to make the matching holes on the other side and we are done. And then we can 3D print it. It's going to use a lot of supports either way I print this, but I think the print orientation best suited for this is actually just standing up like this. Because the angle is not that steep, it can actually print without any supports behind it. Almost all the way up. This is area that needs support, this as well, and all of this needs support. So it's going to be a little bit of a pain to fix, but hey, what can you do? Okay, so we are going to do the reverse now. We're going to choose the body. You see this is bold and this is not. This is the chosen body for now. So I double click and now this is the chosen body. So what I want is the screw hole placement. So let's just hide this body for now. It's chosen, so I don't need to worry. Choose this face and choose this shape binder. Just make sure you choose the face. There we go. Now this is inside here, so we can actually hide the underbody and open the overbody here. And you have the sketch as a reference, so that's perfect. Choose underneath, new sketch. We have the reference, so let's just use bring outside geometry. Then I'm going to make these holes a little bit bigger, 3.75 for the hot melt inserts. You melt them in pretty much and they give you metal screw threads. So just put a circle on each of these. Just be sure you chose the center so it turns yellow. Do that for all of them. And try not to snap it to the actual ring that's on the outside. There we go. Otherwise you have to remove a constraint. It gets annoying. So 3.75. That gives me a little bit of plastic around the actual melt-in screw thread, and that will help me get a little bit of bite so it doesn't fall out. Okay, so then let's do these equal. Perfect, and we can actually go ahead and hide this and make a pocket again. I don't see anything. Is it broken? Too far in, maybe? So this should produce holes. There are no holes here. Okay, I have it at 0. So farther than 5. The holes are not being made, so that's a little bit annoying. I don't really know why. So let's put 4. That should be enough. Reverse. So it goes the other way. Not really. They're not reacting. Okay, so reverse. Did I choose pocket? Yes, I did. So reverse means it should go in there. So let's reverse it again to the other. And click on something. It's not cutting through. So this is one of the annoying parts. This should work. Let's select the reference. Doesn't work. This as a reference? No. Custom direction. Let's see if that works. Still nothing. No, I don't want to do that. Okay, so the pocket did not work for some reason. Is it because I didn't fully constrain the sketch? I think I did. Oh wait, maybe I didn't. Okay, so which of the sketches is this? Oh, okay, I went into the wrong sketch. There we go. So these are fully constrained. They are green. That shouldn't be a problem. It should actually just make hole right through. Maybe I didn't have it selected correctly. There we go. Now it worked for some reason. Yeah, just keep trying. We don't need to worry about the inside part too much. 3mm looks to be fine. 2mm as well. So the insert is 3mm tall, so would be good to have some more plastic inside so it can bite onto, but not really necessary. We can model it in if we need to. So I'll just make it with 2mm for now. And that works. And we are done. So let's see our finished product with everything on. Looks awesome. And this will have magnets inside so it can stick to stuff. The screen, obviously, banana plugs, and the plug-in. I'm not bothering with an on-off switch because this actually has one, the PSU, so not needed. And this should be able to dissipate the heat. So I'm quite happy with the design. You can actually chamfer some of the corners to make it look nice, I guess, if you want to. This and this, for example, make a chamfer. It did it all the way around. Looks a little better, I guess. I can put the chamfer a little deeper. Yeah. The lid underneath doesn't look super great if you do too aggressive a chamfer, obviously, because that shrinks the body. So, but about 2 looks nice. So let's go for that. Okay, time for 3D printing. I'll show a few clips of it printing, and then we do the final assembly. Oh yeah, I forgot the clips. So the clips protrude out this way, so we need to make space for the clips right here and here. So let's just measure these. I almost forgot the most important part, otherwise it won't clip on. So I'll show you right now. Okay, so you can see the clips. That was an important thing I forgot. Give me a second, I have to measure them. So the clips are what keep it in, and there are different depths to them as well. So the start of the clip is 3.8, and the end of the clip is 2.1. So there is a big difference there. So 2.1 should be the lowest point on the clip. 2.1 means 2.1 this way, but I'm not sure it will fit. It will probably break the clip if I make it too tight. So 3.8 is the maximum I will go loose if I leave it out there. So let's go for 3.5 in, and it's about, let's see, 11, let's say 12 wide. So a little slot that's 12 here, and it's practically in the middle of both ends. Yes, it is. So this is 39 and this is 12, so the rest on the both sides is equal distance. So this should be easy enough to make. So let's go for that. Sketch. We're inside the sketch already. Already forgot what I was doing. Let's bring in these. That's the, so we have the size, and the clips go right here. So okay, so equal distance from this to this, and then have 12 millimeters here. So let's make a small cube or square. Same from the other side, it will be exactly mirrored. Okay, so let's first give it the height we needed. 3.5 was our guess. This is mostly guesswork for the clip, because I don't know what it clips into normally, but this should be good enough to be able to slide it in, force it in, and it wedges in, because the clips are actually a little bit springy. And now for the distance from here to here and here to here should be the same. So let's measure one of these out. So let's put in 10 here, and this one was 12, the wide. So 12. So this is obviously too short. Let's see how much we have over here, and just calculate the difference. So it's 17. We have to split 7 for the two. So it's 6 and no, 3.5 each. So 3.5 here is 13.5. Why can't I click this? 13.5. And that should give me 13.5 from there as well. So let's try that. I know you can measure with something else than this, but let's just do it quick and dirty. Yeah, it's the same. So we need the exact same measurements right here, but we don't need to measure. We just need to put the thickness here. 3.5. and then we just make these parallel from that one to that one, from this one to this one, and you have your part. We need to cut in, so another pocket. Let's see if it fails this time. It almost always does when I'm doing this on camera. When I'm doing this for myself, there's never an issue. Okay, so that should be able to slot in. Now we're done. So let's go to the printing. Okay, so I'm back. I couldn't find the power supply I was supposed to use. It's an old laptop power supply, 90 watts I think. So I'm going to use this for now. This is a multi one. This is for my racing wheel. So, and the output up to 24 volts at 4 amps, which should be close enough to what it can handle. Or 20 at 4 amps should give us 80 watts, so that's max. This can handle up to 35 volts in, so that's fine, and at 5 amps, so that should be okay. You can also change out the plug on these ones. Just have to be careful about the polarity on this, and obviously because I'm going to use one of these pre-built ones, I have to find one that matches. No, this is for my racing wheel. I used it that is this correct? This one. Oh, this one? Yeah, the blue one. So let's do this. I don't want to fry anything yet, so let's plug this in. Measure this. Let's put it at 20 something volts. Let's see. That's the last one, 24, 20. There we go. Let's bring out the multimeter. This is just to make sure I didn't plug it in backwards or something. It shouldn't have, because it has one knob thicker than the other one, but I don't know if it's from the same set. So voltage DC should be 20, so 60 should be fine. Yeah, 20 volts, and it's positive, it's center positive, just like I wired it inside the box, I think. So let's hope I wired it correctly. I probably did. So let's plug this in and see if the magic smoke comes out. Ooh, that's tight. Yeah. Okay. It does work. I have this. Okay, so let's choose a voltage. It's 5 volts, drawing 0 amps. Let's get the alligator clips. You can set the amperage as well. It has 2 amps. So I don't know if these wires can handle 2 amps, so let me just turn it off, set that to a lower amperage so it doesn't melt my wires. I don't think it can melt wires, but let's say 200 milliamps, 300. There we go. So let me put something underneath so you can see what I'm doing. It's nice and clear. You turn the voltage on is on because it shows 5 volts. If you turn it off, it goes to 0. See, off. And constant voltage. So it's going to try to keep the 5 volts. And this should short and pull exact amperage. So it's constant current now. Oh, cool. It works. This is not getting hot. Can't feel any heat from the back. So perfect. It works. And this will help me a lot to do voltage injection with constant current, constant voltage. My power supply can't do that. It just beeps when it gets shorted. And I can't choose the amperage either, so. Okay. Thank you for watching until the end. Sorry for the long format video. I had to throw something together for matching PCBway's services. Hope you don't mind. You can expect another video shortly. Have a nice one. Bye.